Okay, time for something a little more interesting than just the basics of probability. Okay, it turns out, and I think you'll probably agree with me with this, probability is super counterintuitive. Everybody, it doesn't matter who you are, mathematician, scientist, biologist, doesn't matter, probability is super counterintuitive. So here's a case study that shows you what I mean. So in the book Gut Feelings, if you want to read this book, I've got the reference for it there. The author describes a study where he asked 24 doctors to estimate the following probability. I'll show you in a second. What I want you to keep in mind is that only 8 of those 24 doctors were even remotely close, and these are medical doctors. Here's the situation. In your clinic, the probability that one woman has breast cancer is 0.8%. So very, very small. If a woman has breast cancer, the probability is 90% that she will have a positive mammogram. The mammogram is the test to detect breast cancer. If a woman does not have breast cancer, the probability is 7% that she will have a positive mammogram. Okay, now that 7% is your false positive rate. So the question is this: if a woman who has a positive mammogram, imagine a woman who has a positive mammogram, what's the probability that she actually has breast cancer? So think about this. They actually tested positive. What's the probability that they actually do have the disease? So the choices are less than 25%, between 25 and 50, 50 to 75, and more than 75. Put me on pause, think about it, and select your answer. Okay, now take me off pause. I assume you have me off pause. Let's actually play with this problem a little bit. So we're going to go into Google Sheets. All right, so here I am in Google Sheets. Open up a new one for yourself. And I'm going to label the columns of a Google Sheet has cancer and does not have cancer versus test positive and test negative. And what we're going to do, as the slides suggest, is we're going to send 100,000 people into your clinic. So the 100,000 is just kind of a made up number. Let's just say big number of people going through your clinic. So I'm going to try and put these side by side. Let's see what we can do here. All right, here we go. Let's make the slides a little bit bigger. Okay, we're going to push 100,000 people through. Now, if there is a 0.8% chance that someone has cancer, that means in this column, this cell right here, 0.008, a 0.8% chance of all of those folks, only 800 of those 100,000 actually have cancer. Whereas the rest, 0.992, the other 99.2% of people do not. And just to double check, those two things do add up to 100,000. So I took 99.2% of these people, they do not have cancer. 0.8% of those people do have cancer. Okay, that takes care of this first bullet. If a woman has breast cancer, the probability is 90% that she will have a positive mammogram. So if I'm here, then I have a 90% chance of actually having positive mammogram. So if I'm in this 800, then I've got a 90% chance of being in the positive category. So there's 720 people that actually fall there, which means everybody else, that's 10%, everybody else actually had a false negative. Okay, that's the second bullet. If a woman does not have breast cancer, so now I'm in this column, the probability is 7% that she will have a positive mammogram. So I've got a 7% false positive rate. So 7% of these people are going to test positive. Look at how big that number is. This is where people's intuition breaks, right? You get a really, really big number of people that are actually getting false positives. Excuse me. And everybody else is actually getting a true negative there. So the question is, imagine a woman who has a positive mammogram. Right, so what I'm interested in is the probability that she actually has breast cancer. So I'm interested in the probability that I have cancer given a positive test. Okay, that's the thing that I'm interested in calculating. So let's see. Well, let's see. If I have a positive test, that means I'm now in this row. Well, I need to finish filling out that row. Okay, so that's that cell plus this cell. So those are all the people that have positive. And just to complete the whole thing, this one has to be all the negative tests added together. And as a sanity check, those add up to 100,000. That's good. Okay, if I'm given that I have a positive test, the probability that I have cancer is that cell divided by this cell. And now before I press enter here, stop and come back to your multiple choice. How many of you said C or D, like really high probability? I have a woman that has a positive test, the chance that she actually has cancer. Excuse me. Excuse me again. I promise you're not alone. Most people will actually overestimate and say it's really, really high. And it turns out it's about 9%. Holy moly. There's only about a 7% or 9% chance that a positive test means cancer in this for this study. Okay, 9%. That's humongous. And where people lose their intuitive sense is that there is such a massive false positive rate because there are so many people in the do not have cancer category that you just lose your sense of that big false positive rate, and it leads people to believe that the false, I'm getting myself tongue-tied here. Let me try again. The massive false positive rate leads people into a false sense of what the true positive rate is going to be.